Business today is increasingly heated battle for consumer and market share. Fast-moving competitors and the troublemaking new entrants, rapid change across all industry require business to accelerate the software delivery. Business leaders, therefore, must be increasingly agile. They even must be extremely open-minded and responsive to change. This is, of course, not even the only challenge. There is another big challenge by replacing the product or the service by a digital one. Let's see an example. So, for those they don't know about the Fortune 500, there is a magazine in the US where it lists the top 500 companies based on the fiscal year revenue. So 50% of these companies has gone. It's not exist. They has been replaced by company that use the technology to deliver the customer value faster, better, and cheaper. If anyone remember or knows the Blockbuster company, which was one of the top companies that renting movies in the US, in 2004 it has about 10,000 stores, 5,000 of them only in the US. It has revenue in billions. This company has been kicked out of the market and replaced by a startup company called Netflix back in 2010 in that time. In 2010, Blockbuster has big problem and after a couple of years, it's completely gone. As we can see, it is not just that this company affecting some of the revenue for the competitor. It leads to that this company completely vanish. This is why technology is changing the way that we're doing our business. It's changing the way that we deliver our services for our end user, how we deliver the products. What is the value for Blockbuster for 10,000 stores in the US while Netflix delivers the movies using an app on the TV for everyone in his home? And for those companies that they don't understand the digital disruption that's happening, they will face the same fate. This is why we usually say that the current 500 today will face the same challenge tomorrow if they don't understand the digital disruption and how to use the technology to get innovation. So this is why usually I will say business and technical innovation, it is not an optional anymore. It is the only way to survive. As we saw, it is not just affecting that the companies may get less revenue, it just may lead to the company to be completely out of the market. This is why digital transformation is an opportunity for some companies and will be a disaster for others. Let's get more insight about digital transformation. Technology is shaping how business plan for innovation and growth within their market. The importance of digital transformation is urgent. Since 2000, as we explained before, 50% of the Fortune 500 companies are gone due to digital disruption. We see companies responding by creating digital strategy across four core as we can see. The first, engaging their customers, empowering their employees, optimizing their operations, and transforming their products. So they start looking on what could be digitalized. Everyone is aware of how important this is. Look at company like, for example, Uber, for example, they have created a digital model for the taxi industry that has allowed them to suppress every other taxi company by double or more. Recently value 62.5 billion. They have created a significant shift in industry that has been largely untouched for decades. Why is transformation important? If we start looking at some numbers in the next few years, in 2020, 1 million new devices are expected to come online every hour. The connectivity between people and data is creating billions of new relationships that are driven not only by data, but by algorithms that keep customer engaging and buying. In 2020, average age of S&P 500, which is a stock market index, is expected to be 12 years old compared to in 1960 which was 60 years. So, which means that it will be rapidly change the top companies. For digital transformation, mobility is the universal catalyst and cloud is a great enabler. How are you planning for digital transformation? Do you have the right people and the right technology in place to build your digital vision? How can you use the technology to shape your future? This is the main idea of digital transformation. Let's look at some other studies and some numbers. So, from Gartner, they show that organizations require a well architecture, multidiscipline, hyper integration platform, which means that cloud and on premises, and supporting API management to support policy management and service governance. When we start developing our software, and we usually have our software development lifecycle following any process or framework. But the main idea, I have list of requirement or user story or product backlog items. And then we start building that, developing the requirements and moving from one stage to another. And this is usually is the typical software development activities and practice. And behind the scene, there is a lot of activities happen like build automation, testing, and many other things. So the time starting from the beginning to the end of the deployment, this is the lead time. And this could be 5 hours, could be 5 days, even months. And the time between the deployment, this will identify the frequency of the deployment. This is why it's very important to understand that frequency of deployment, it is not the lead time. But of course, the lead time affecting the frequency of the deployment. The most important, how the pipeline, I'm not talking about CI/CD pipeline, I'm talking about the software development lifecycle pipeline is a solid, and this is more important than to be fast. John Olespo Delivery Cycle Chart. John Olespo is a co-author on DevOps Cookbook, and he is a continuous delivery leader who is improving the continuous delivery at Flickr and then moved to Etsy, and I think now he is a vice president. So John has created what we know as delivery cycle chart. So John explained his idea and created this chart, and he's explained that if we wait for a long time and then deliver into production, we will deploy a massive amount of change, including many lines of code, a lot of feature, a lot of things that can go wrong. But if we minimize that to the minimum as much as we can, it means it has a small amount of change and we will deploy more frequently. Because a small amount of code change and more frequently, it means less time to test, less time to understand the impact, and if there is something wrong, taking less time to fix, less time to detect about the problem. It is all lead to have a smooth deployment and quick fix if there is any problem. And finding that is very quick. And this, of course, unlike when we have a lot of a change and long time to deploy. And we can see the relation as we go up with less change, we will have less problems and better delivery. But organization wrongly understands the opposite, that when they stretch and when they have more time to deliver, then this will give them the ability to have a lot of regression testing and full testing to ensure that everything is complete. So let's understand the difference between lead time and cycle time. Lead time is measure the total time from the creation of the work item to the completion. But cycle time measures the time it takes from the team to complete the work once they begin actively working on them. So the difference between lead time and cycle time will cover the part of proposing and analysis for the ideas, while the cycle time will cover building the ideas. And for both of them, creating the ideas and building the ideas, this will be the lead time. There is an industry studies that done by two organizations. One of them is DORA, or DevOps Research and Assessment, and the second is Puppet. And both of them, they collecting data from different companies about DevOps adoption for different companies. The number of companies are around 27,000 companies. So what they found year over year, that the company moved to more frequently deployment in production, and this number increased over years. So if we look, for example, for high performance DevOps example, we can see that Amazon deploy in production more than 1,000 deployment per day. Netflix, it is the same. HubSpot, 300 per day. Etsy, this is where John Olispo working, is 50 deployment per day. IMVU, 50 deployment. And Microsoft, Google, Mozilla, 2 to 3 weeks for new release. So let's see why Kanban is the best for DevOps. And to understand that, let's see Scrum vs Kanban. When we have a Scrum, we usually have a sprint backlog. And even if we completed one items, we will not be able to deploy this user story or product backlog item to production because we have a sprint backlog which we need to have a complete integration test and regression test with all the sprint backlog scope. And usually we will deploy all the sprint backlog in production. But when we look at Kanban, it is completely different because in Kanban we have different user stories, but we don't have a scope for the sprint because we don't have a sprint. This is why as long as we completed the user story, we can deploy it in production. Completed another user story, then deploy it to production, and so on. So we don't have limitation to deploy in production if we completed our work. This is why the lead time in the Scrum is limited and it needs to wait for the other item in the sprint backlog, but the lead time in Kanban, it can be very quickly as it has no dependencies on other items for the scope of the delivery. This is why if we get back to John Olispo delivery cycle chart, we will see that only by using Kanban, we can minimize the change to the minimum. But how to improve and speed the change? First, I must understand the lead time and how long it will take, for example, to complete development of one feature from the beginning to deploy it in production. So I must understand that. Once I understand it, I start optimizing that to the maximum. We start by understanding adding requirement to the backlog. We start look at how long it will take to refine this requirement. And then the time that will take to develop the code and testing the application, then requesting to have provide a QA environment, so deploying the application to provide, for example, an integration testing. Then approval workflow to have the environment created. Then provision the environment, configure and deploy the application, test and build, request operation to deploy to the production, including the approval workflow time, configure and deploy to production. So we start understanding the complete life cycle, how long it will take. So for example, this example, it took 25 hours and 20 minutes to deploy small feature from the beginning to the end. And we start looking at how we can improve that. So we start looking at the repetitive task, either manual or automated, because again, the automated is not the end of the story, because you can have an automated task, but it is slow. It can be faster. It can be optimized. Also, it can be not reliable. So we start looking at all the tasks and see the repetitive. Then we start looking at the task duration, and then waiting time between moving from one task to another, and reliability of the execution. And we start eliminating the bottleneck, identify the constraint which is causing the delay, try to reduce the impact by automation or process change, monitor for improvement, and repeat. And this is continuously ongoing process during the DevOps transformation or optimization. Visualization. Again, I will say it is the most important point in DevOps and in any software development practices. Because the main idea is if you can't visualize, you don't have visibility, you don't have transparency, we don't know where we are, we don't know where we are going, and we don't know how we can fix. This is why it's very important to visualize. So visualization is very important for visibility about where we are, which is the current, how we are doing is the progress, and where we are going, the goals. The best option to understand the impact of the DevOps, for example, is to look before and after to see the change. It is just the same idea like when you want to go for the gym and you want to lose some weight. You will find that you will go and measure your weight or go for the scale every day. And if you go for bodybuilding.com, you will find that they advise you to create a profile and you start measuring and take picture in every day. And this is the main idea of having visualization of the transition over time. There is a transition in every day, and we would like to see that. Seeing the progress over time will help us for many things: motivation, correction, adjustment. Because if I can't see what is the status of what I am doing, I will not be motivated. I don't know if what I am doing is correct or not. How can I fix? How can I improve? So we should have dashboard to visualize the current DevOps state as well as the progress in quantitative over time. The dashboard should allow detailed views as well as roll-up or consolidated views across the end-to-end, like all teams, all projects, all components, and all activities. The main idea here I'm trying to explain is I need to have this visualization and dashboard across a roll-up of all organization, all a very small granular level across the component or the team, so I can have visibility and transparency. I will dare to say without a visibility of the progress, we will lose the motivation to continue and end up with nothing. Let me give you the example of body transformation. If we look at body transformation, and again, it is the same, we started looking at in week 1, we do that in week 4, in week 7, and this progress is very important to understand where we are, what we are doing, and where we are going. And DevOps transformation is not far from body transformation. It must visualize the current, the progress, and the goals. As we understand now the importance of visualization, let's talk about the importance of measuring DevOps. We can't improve what we don't measure. We have to monitor measurement over time, what we call the trend. So let me give you an example about status report vs trend report in Azure DevOps. In a status report, it just gives me the number. So for example, if I have 156 test cases, then I can see this report tell me like I have 68 test case passed, 53 not run, I have 25 failed. So I understand from this report the status of the test cases or the test run. But I want to understand the change over time. This status report is not enough. In the change over time, it displays a change of the value over the time. And this is what we call the trend report. And to measure the DevOps, I need to have a trend report and measuring over time for all the KPIs that I'm going to measure the DevOps. And the first one is the frequency of the deployment. How often you release new version of a specific product or service measured by number of deployments per month, week, day, or hour. The second is the speed of deployment. So if you measure the number of deployment, it's not enough, because also we need to understand how long it will take for single deployment, numbers of hours or maybe minutes or days. This could include also the approval process and so on. The next is the change in the lead time. As we understand now what is the lead time, it is very important as well is to measure the change, because we would like to reduce the lead time, and this is why it's very important to measure it. The next one is the speed of the build verification, the total time for build to go through the QA cycle, how long it will take to verify or testing that this build is ready to go. Another one is the change the fail rate. And the fail rate here for everything, for build, for deployment. It's very important to keep also tracking that over time. So all our KPIs, we will look at them as a trend or a change over time. The next one in incident or defect per volume. So how many incident or defect find by volume. The next one, mean time to detect, which is the time required to detect a problem in production. And here the detection is not by reporting, but is by analysis and understand the problem before it happened. And mean time to repair or to fix is how it will take to fix the problem once we found. The blue KPIs, this is the agility performance indicator, and the purple KPIs. This is reliability performance indicator, and it's very important to measure agility KPIs and reliability KPIs. There are many other KPIs, and what I show here just an example. We can even create our own KPIs. For example, let's say that you found that it took long time to start testing and you want to improve that. So what you need to do is just to define a KPI for that. Let's say, for example, time to start testing. And then start measuring the change over time to understand if you improve or if you are the same or even get worse. The main idea that we look for the bottleneck and try to define a goals to improve that and put a KPI with measurement and visualizing this measurement over time so we can understand the current and the progress and if we are moving or not. Frequency of deployment. As we now understand that it is very important to visualize the frequency of deployment so I can understand again the current, where I am, the progress, what I am doing, and the goals, where I am going. And we can move from one target to another to see that change over time. So let's look about other visualization example. As we can see here, waiting time to start testing, build the failure rate. Another is frequency of deployment, build verification time. I can define the KPIs that give me more indication about the transition and the progress, and we need to move very quickly to deploy in production if we're working with more frequently. So anything stop me or slowing me from the speed of deploying in production, it will be a bottleneck that I need to measure and change, improving over time and have a visualization for that. This is a very good example by Microsoft Engineering Scorecard that they visualize the progress of their engineers. And again, they are not putting the KPIs for the people. We usually put the KPIs for the automation and for the pipeline and the tools and the work progress, but not for people. For example, they measure the time to build, the time for self-test, the time to deploy, the time to learn, but they don't measure the original estimation or the completed hour or team velocity or team capacity. As you go more frequency of deployment, you will get less attention for estimation because you will deliver at the end of the day. Or what you are looking for is just improving that and learn from that.